Okay, this is the final exam for Calc 2 of fall 2021. We get 2 hours on this exam. Solve the following differential equation. This is a pretty easy separable equation. If we multiply dx over and multiply y over, we will get y dy is equal to e to the x dx. Integrating both sides, we will get y squared divided by 2 will be equal to e to the x plus c. Applying our initial value, we're substituting our initial value in. When x is equal to 0, y is equal to 1. We're going to get 1/2 is equal to e to the 0 plus c. E to the 0 is equal to 1. So we're going to get 1/2 equals 1 plus c. Therefore, c will be equal to 1/2 minus 1, which is going to be negative 1/2. So y squared divided by 2 will be equal to e to the x minus 1/2, and this will be our final answer. We just did a separable. Most likely we're going to have a linear. In this case, we do have a linear. In this case, we need to make sure that y prime is by itself, but it's not in this case. So we need to multiply this entire thing by 1 over x to the third power. Doing so, we will get y prime plus 5x squared divided by x to the third power will give you 5 over x, like this, times y, will be equal to x to the fourth power plus 1 divided by x to the third power. Now we can find our integrating factor, e to the power of 5 integral of 1 over x dx. This will be equal to e ln absolute value of x times 5, which is equal to x to the fifth power. Set this as mu. Multiplying mu by everything, we get mu y prime plus mu 5 divided by x times y is equal to x to the fourth power plus 1 divided by x to the third power times mu. Applying our knowledge on implicit differentiation, or the reverse of that, we will get mu times y, derivative of this. Take the integral of both sides, will be equal to integral of this side. The integral of this side will be equal to, if we substitute mu back, we will get x to the fifth power divided by x to the third power, which is going to be x squared. So x to the fourth power plus 1 times x squared dx, which will be equal to the integral of x to the sixth power plus x squared dx. The integral of a derivative is just whatever's on the inside. So it's going to be x to the fifth power times y will be equal to x to the 7 divided by 7 plus x to the third power divided by 3 plus c. Now solving for y will be equal to x to the 7th power divided by 7 plus x to the third power divided by 3 plus c. All this multiplied by 1 over x to the fifth power. And this should be our answer. Find the area of a triangle with the vertices this, this, and this. If you forgot the formula, that's okay. You can derive it. Suppose we have a parallelogram. This is A, this is B. This will be A sine theta if this is theta. Based on this, we can conclude the area for this parallelogram will be base times height, which is going to be magnitude of B times the magnitude of A sine theta. This should look familiar to you because this is the same thing as A cross B. Why did I tell you this? I told you this because the area of a triangle is going to be equal to 1/2 of area of a parallelogram. In this case, it'll be a square. So what is our A and what is our B? We need to find our A and our B, lowercase a and lowercase b. A will be equal to AB, which will be equal to B minus A, which is equal to B, which is 3, 0, 1, minus A, which is negative 2, 2, 1. This will be equal to negative 3 minus a 2. It's going to be 3 plus 2, which is going to be 5. 0 minus 2 is going to be a negative 2. 1 minus 1 is going to be 0. B will be equal to AC, which will be equal to C minus A. C is 0, negative 1, 0, minus A, which is negative 2, 2, 1. This will be equal to 0 minus a negative 2 will give you a positive 2. Negative 1 minus a 2 is going to be a negative 3. 0 minus 1 is going to be a negative 1. Now, based on this formula, we need to do A cross B. A cross B will be equal to the determinant I, J, K, A, which is 5, negative 2, is 0. B is 2, negative 3, negative 1. This will be equal to I, negative 2, 0, negative 3, negative 1, minus J. We switch signs, so now it's a negative. 5, 0, 2, negative 1, plus K, 5, negative 2, 2, and negative 3. This will be equal to I. Doing our determinant, we're going to do 2 times negative 1, which is going to be 2, minus J. 5 times negative 1 is going to be negative 5, plus K. 5 times negative 3 is going to be a negative 15. Negative 2 times 2 is going to be a minus 4. So do minus 4 is going to be minus, or it's going to be a plus 4. So this will be equal to 2. Negative 5 is going to be positive 5. And this will be a negative 11. Now we need the magnitude of A cross B. The magnitude of A cross B will be equal to the square root of 2 squared plus 5 squared plus 11 squared plus negative 11 squared. So our area of this triangle will be equal to 1/2 magnitude of A cross B, which is going to be 1/2 2 squared plus 5 squared plus 121. You don't have to simplify this if you don't want to. Find the equation of the plane that contains the point. This, and this. These are the same points from earlier. To find the equation of a plane, we need 2 things. We need a point and we need a direction, which is n. N is equal to AB cross AC, which is equal to A cross B. This is from what we said earlier. We know what A cross B is, which is n. Therefore, this is going to be equal to what we found earlier, which is 2, 5, and negative 11. 2, 5, and negative 11. Based on this, our equation of the plane is going to be 2, 5, negative 11. This is n times x plus 2. We can use just a for any, we can use any point a, b, or c. So in this case, we'll just use a. And then it'll be it'll be y minus 2 and z minus 1. This will be equal to 0. So doing dot product of this, multiplying it out, we're going to get 2x plus 2 plus 5y minus 2 plus be a minus 11 z minus 1. This will be equal to 0. So this is our final answer. Use Taylor series polynomials or series to answer the following questions. Look at your equation sheet. From your equation sheet, you will see that ln of 1 plus x will be equal to equals 1 of negative 1 to the n minus 1 x to the n divided by n. This will be equal to, plugging in n equals 1, we will see that we will get x. plugging it in equals 2, we will see that this will be a minus x squared divided by 2 plus plugging it in equals 3, we will get x to the third power divided by 3 minus x to the fourth power divided by 4, and so on, dot, 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 plus dot, 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 and so on, right? Based on this, the limit as x goes to 0, this and this, the only difference between this is it's x squared and this is x. So all we need to do is replace every x we see with an x squared. So we're going to have x squared minus x squared is going to be x to the fourth power divided by 2 plus x to the third power, but x is equal to x squared. So x squared to the third power is going to be x to the sixth power divided by 3 minus x to the fourth power divided by 4. Replacing x with x squared, we will get x to the eighth power divided by 4 plus dot, 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 and so on. Take all this divided by x to the eighth power minus x squared, this part right here, x squared, plus x to the fourth power divided by 2 minus x to the sixth power divided by 3. Notice that this term will cancel, this term will cancel, this term will cancel. We're just left with this, basically. So this will be equal to the limit as x goes to 0 of negative x to the 8 divided by 4 over x to the 8, which will be equal to negative 1 over 4. If you take this, flip it and multiply, you get negative 1 over 4. Compute this. The trick about this is seeing that they both have the same power. Based on this, we can combine these two powers, or these two bases, because they have the same power. This right here is very similar to a series that we see on the equation sheet. This is very, very similar to cosine x. Cosine x is equal to this, x to the 2n divided by 2n factorial. The only difference being pi over 2 is where x is. Therefore, we can set x is equal to pi over 2. And this is true. Cosine of pi over 2 will give you your answer. And cosine of pi over 2 at 90 degrees, the x value is equal to 0. Find the macaroni series, that is the Taylor series about x equals 0 of this. Make sure to include a formula for its round term. Okay, taking another look at our formula sheet, we can see that e to the x power will be equal to x to the n divided by n factorial. Therefore, e to the 4x, the only difference here being x and 4x. So let's replace every x we see with a 4x. This x will be a 4x. So we do a 4x to the n power divided by n factorial. This will also be equal to n equals 0 of 4 to the n x to the n divided by n factorial. So now x to the third power e to the 4x. This will be equal to, what was 0? If we take this and multiply it by x to the third power, notice x to the n times x to the third power will be equal to x to the n plus 3. So this will be equal to 4 to the n, x to the n plus 3, all divided by n factorial. And this should be your answer. Consider the series. Determine the radius of convergence. When we hear that, we always want to do ratio test. And it's very simple to do ratio test. So n equals infinity of a of n plus 1 over a of n. This will be equal to the limit as n goes to infinity with absolute value of x minus 2, n plus 1 over n plus 1 times 5 to the n plus 1 times n to the 5n divided by x minus 2 to the n. This will be equal to the limit as n goes to infinity. This term will cancel, leaving us with the x minus 2 on top, 5n, and this 5n will cancel, leaving us with a 5 on the bottom, and the n and n plus 1, they remain. Now we can bring the constant out in front, which is the absolute value of x minus 2 divided by 5. The limit as n goes to infinity of n divided by n plus 1. Multiplying this top and bottom by 1 over n will give us x minus 2, absolute value x minus 2 divided by 5. The limit as n goes to infinity of 1 over 1 plus 1 divided by n. This term right here is equal to 1. Therefore, this will be equal to absolute value of x minus 2 divided by 5, which is going to be less than 1. We set it less than 1 because by ratio test, if the limit as a of n plus 1 over a of n goes, the limit as n goes to infinity of absolute value of a of n plus 1 over a of n, if this is less than 1, then it will converge. That's why we set it less than 1. So absolute value of x minus 2 will be less than 5 if we multiply 5 over. Therefore, we can see that our radius of convergence will be equal to 5. Determine the interval of convergence. To find the interval of convergence, we need to see this is absolute value of x minus 2. It's a piecewise function. So x minus 2 is less than 5, but also negative x plus 2 is also less than 5. Therefore, x will be less than 3. Sorry, x will be less than 7. And this bottom one, negative x, will be less than 3. And therefore, x will be greater than negative 3. So, negative 3 is less than x, which is less than 7. We need to test the endpoints to see if they converge or diverge. So when x is equal to negative 3, what do we have? When x is equal to negative 3, we have negative 3 minus 2, which is going to be a negative 5. So we have summation is n equals of negative 5n divided by n, 5 to the n power. We can see the 5n and 5n will cancel. This will leave us with a negative 1 to the n on top. Negative 1 to the n on top divided by n. We can see that this is an alternating series test and it will converge by alternating series test. We need to say 4 things. If we set b of n is equal to 1 over n, this needs to be continuous, positive, so b of n is greater than 0, and it needs to be decreasing because the denominator is increasing, and the limit as n goes to infinity of 1 over n will be equal to 0. Since all 4 of these conditions are true and they're met by b of n, we can say that this series will converge by alternating series test. When x is equal to 7, plugging in 7, we're going to get 7 minus 2, which is just 5 to the n. So we're going to have this 5 to the n divided by n, 5 to the n. This will be equal to the summation. This 5 to the n will cancel, leaving us 1 over n. We know this is divergent by a harmonic series. So we can conclude when x is equal to 3, sorry, negative 3, we're going to get square brackets around that because it's convergent. And when x is equal to 7, it's going to be divergent, so we use parentheses. And this is our interval of convergence. Compute the following integrals. To do this, we'll use trig sub. Recall that if it's in the form of x squared minus 9, sorry, x squared minus a squared, we'll set x is equal to, what is it? It's I think secant theta. Yeah, it is. So in this case, we'll set x is equal to a secant theta, a being 3, secant theta. Therefore, dx, where do I write xd? Dx will be equal to 3. Derivative of secant is going to be secant theta, tangent theta, d theta. Let's just look at this part right now. Looking at just this part, actually no, let's not do that. Let's just plug it in. Why not? It's going to be a big mess. But it's going to be 3 squared, which is going to be 9 secant squared theta minus 9. This will be all over x to the 4th power. But now we're in theta, and x is equal to this. So let's just do 3 to the 4th power secant to the 4th power theta. Replacing dx with what it is, which is this big jumble of mess here, is going to be a 3 secant theta, tangent theta, d theta. Now we can simplify this a lot more. Integral, notice this 3 and one of these will cancel. This secant and this one of these secants will cancel. And this top thing right here will be equal to the square root of 9 secant squared theta minus 1. This will leave us with 3 to the 3rd power secant to the 3rd power theta. And we have tan theta d theta still. Recall that sine squared theta plus cosine squared theta will be equal to 1. Dividing everything here by cosine, we will get sine divided by cosine, which is going to be tangent squared, plus 1 will be equal to secant squared. Therefore, secant minus 1 is going to be tangent squared. So we can write that here. Take this 9, bring it out in front, or bring it outside of the square root. We're going to get 3. Square root of secant squared theta minus 1, which is going to be tangent squared theta. This will be all divided by 3 to the 3rd power secant cubed theta times tangent theta d theta. This will be equal to, notice this 3 and one of this will cancel. This will be equal to square root of tangent squared is going to be tangent theta. This tangent and this tangent will make tangent squared theta all over 3 squared secant squared theta d theta. This may be a little bit complicated for some people. 1 over 9 integral of tangent squared theta divided by secant cubed theta d theta. This took me a second to do because if you set u as anything, trying to do a u sub, it wouldn't work. So what you need to do is basically go back to the old-fashioned tangent is equal to sine divided by cosine. So we have tan or sine squared divided by cosine squared will be equal or divided by secant cubed is going to be equal to 1 divided by cosine cubed theta d theta. Simplifying this, we will get 1 9 integral. Taking this, multiplying, or flipping and then multiplying, we're going to get sine squared theta, cosine to the 3rd power divided by cosine to the 2nd power, will just give you cosine theta d theta. This will be equal to, actually let's do a u sub. Notice the derivative of sine is going to be cosine. Therefore we set u is equal to sine theta. Therefore du will be equal to cosine theta d theta. This will be equal to 1 9 the integral of u squared du. This will be equal to 1 9 the integral of, 1 9 u to the 3rd power divided by 3 plus c. Substituting u with what it is, we're going to get 1 9. 9 times 3 is 27. Let's just put that here. 1 over 27 sine to the 3rd power theta plus c. Notice we started with x. Now we're in theta. So we need to rewrite this back into x. From this, we can see that x divided by 3 is equal to secant theta. We know that cosine is adjacent over hypotenuse. So secant is 1 over that, which is going to be hypotenuse over adjacent. Therefore, if we draw a triangle, we will get hypotenuse being x, adjacent being 3. So therefore, this angle right here will be equal to x squared minus 9. From this, we can find this 1 over 27. Sine is opposite over adjacent. It's going to be opposite over adjacent. So it's going to be square root of x squared minus 9 divided by adjacent, which is 3. Actually, what is sine? Sine is opposite over hypotenuse. Why did I say adjacent? I was thinking about tangent. So it's going to be this over this, x. So we're going to have an x here, actually. And this will be all to the third power plus c. And this is our answer. To solve this is a very basic integration by parts. We got to do it twice. I've done so many of these that I just know. U is equal to LIATE. I mean, U is whatever comes first in LIATE. In this case, we can set U is equal to x squared. Therefore, du will be equal to 2x dx. So dv will be equal to cosine x dx. So v will be equal to sine x. Applying our integration by parts formula, we're going to get v times u, which is going to be x squared times sine x minus the integral of v times du, which is going to be, take the 2, bring it on front because it's constant, x times sine x dx. Now we got to apply integration by parts again. We said u is equal to x, du will be equal to dx. dv will be equal to sine x dx. So v will be equal to negative cosine x. Applying our integration by parts. Actually, this part will just stay the same. Minus 2. Now applying our integration by parts, we're going to get negative x cosine x minus integral. This negative and this negative will make a positive. So we put positive cosine x dx. This is equal to x squared sine x minus 2 negative x cosine x plus antiderivative of cosine is going to be sine x plus c. And this should be your answer. Determine whether this is convergent, divergent, or whatever, blah, 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 right? To do this, you have to realize this may seem a little bit complicated. So you would start trying to do some u subs. You'll soon figure out that u subs does not work. So we want to think about comparison theorem. What can we compare this to? Something that we always want to compare something to is obviously the p-test, something that has p-test 1 over x to the power of whatever, right? In this case, we have 1 over x right here, but we have this right here. What is this? Let's look at this a little bit closer. 4 over e to the x squared. Notice that the graph of e is going to look, why is my graph so weird? Graph of e is going to look something like, what does graph of e look like? Shoot, I forgot. It's going to look like this. I think. It'll look something like this, basically. I hope. This is always positive, so we know this entire term is going to be positive all the time. Therefore, if we say 1 plus 4e to the negative x squared divided by x, this term right here is always positive. Therefore, this numerator is always going to be bigger than if we remove it, 1 over x. And we can conclude, because the integral from 1 to infinity of 1 over x dx will diverge by p-test, where p is equal to 1. The integral from 1 to infinity of 1 plus 4e to the negative x squared divided by x dx will diverge by comparison test, by the comparison theorem. Because something's smaller, if something smaller diverges, that means the thing that's bigger than it will also diverge. Determine whether each of these following series are divergent, conditionally convergent, or absolutely convergent. You can use the fact that ln x is less than x. This is a graph of ln x. This is a graph of x. So therefore, ln x is always less than x. Okay, looking at this, we're going to do an alternating series test first. So by alternating series test, we must state 4 different things. If our b of n is equal to 1 over 6 ln n, it must be continuous, and it must be decreasing, because we can just say the justification for why it's decreasing is because the denominator is increasing. We can just say this here because the only variable n is on the bottom. If it's not, if there's some on the top, you have to take the derivative and set it less than equal to 0. Set it less than 0. Continuous decreasing because the denominator is increasing and it's positive, so b of n is greater than 0. And it needs to be, and the limit as n goes to infinity of 1 over 6 ln n must be equal to 0. And in this case, since all 4 of these conditions are met, we can say this will converge, series will converge. Series will converge by alternating series test. Now we need a test to see if this is absolutely convergent, conditionally convergent, and which one it is. My English is not Englishing today, but it's fine. To do this, we'll take the absolute value. Equals 2, absolute value of negative 1 to the n, divided by 6 ln to the n. This will be equal to n equals 2, 1 over 6 ln n. Here we can use a comparison test. 1 over 6 ln n. This is, because we know this is always less than, since we know this is always less than n in the denominator, this will be always greater than 1 over 6 to the 6 times x. Let's call this a of n. Let's call this b of n. We must say that a of n and b of n are both positive. Now we can do direct comparison. We know the summation is n equals 2 to infinity of 1 over 6x. We know this is going to diverge because it's the harmonic series. It's a multiple of the harmonic series. Therefore, because this diverges, therefore L and N will diverge by direct comparison. So we can conclude this original series, if we said this is OG series, we can say this original series converges conditionally. Now we need to see if this is convergent or divergent, or conditionally convergent, absolutely convergent, blah, 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 whatever, right? We can use the ratio test. The limit as n goes to infinity, the absolute value of n plus 1 over a of n. This will be equal to the limit as n goes to infinity of the absolute value. To ignore this part because we're taking the absolute value, right? It's going to be n plus 1 times pi to the n plus 1, all divided by 5 n plus 1 minus 1 is going to be 5 to the n, times 5 to the n minus 1, divided by n pi to the n. Notice we don't have any x's, so we can simply just drop the absolute value sign. Also notice 5 to the n minus 1, this is equal to 5 to the n divided by 5. This is going to be equal to the limit as n goes to infinity. We can see this pi to the n and this pi to the n will cancel, leaving us with a pi on top. And this 5 to the n, this 5 to the n will cancel. Normally this would leave us with a 5 to the n where it's just 5 on top, but this would be 5 on the bottom because of this. N plus 1 wasn't affected, and this n wasn't affected. Now, multiplying both top and bottom, let's actually bring the pi over 5 in front of the ln, in front of the limit, sorry, as n goes to infinity of n plus 1 divided by n. Multiplying the top and bottom by 1 over n, this will give us pi over 5, the limit as n goes to infinity of 1 plus 1 divided by n over 1. This will be equal to pi divided by 5, because this entire term right here is going to equal 1. Pi divided by 5 is 3.141 divided by 5, which is always going to be less than 1. Since this is always less than 1, the series will will diverge by ratio test. Series diverge by ratio test. Wait, sorry, what am I saying? I was right the first time. If it's less than 1, it will converge absolutely, because all terms are positive. Find the angle between the vectors a and b. You do not need to simplify this answer. We need to know that a dot b is going to be equal to the magnitude of a times the magnitude of b cosine theta. Solving for theta, we will get theta is equal to arc cosine, or inverse cosine, of a dot b divided by magnitude of a times magnitude of b. Let's solve for a dot b first. A dot b will simply be equal to 2, negative 1, 4 dot 3, 4, 1. This will be equal to 2 times 3, which is going to be 6. Let's write it out actually. 2 times 3 plus negative 1 times 4 plus 4 times 1, which will be equal to 6 minus 4 plus 4, which will be equal to 6. Now let's find the magnitude of a. The magnitude of a will be equal to the square root of 2 squared plus negative 1 squared plus 4 squared. This will be equal to the square root of 4 plus 1 plus 4. Plus 16, which will be equal to 21. Square root of 21. Magnitude of b will be equal to the square root of b, which is 3 squared plus 4 squared plus 1 squared, which will be equal to 9 plus 16 plus 1, which will be equal to 9 plus 1 is 10. 10 plus 16 is going to be 26. Now plugging everything into theta, theta will be equal to inverse cosine. That was ugly. Inverse cosine of a dot b, which is going to be 6, divided by magnitude of a, which is 21, times magnitude of b, which is 26. And this is our answer. Find the vector projection of a onto b. The vector projection of a onto b will be equal to this. This will be equal to a dot b divided by the magnitude of a squared times Oh, I wrote this backwards, sorry. I was thinking of the vector projection of B onto A. It'll be like this. We know what A dot B is. We did that earlier. It's going to be 6. We know what magnitude of B is. The magnitude of B is going to be square root of 26. So it's going to be square root of 26 squared times B, which will be equal to 6 over 26 times B. B is going to be equal to 3, 4, and 1. So it'll be this times 3 comma 4 times 6 divided by 26 comma 1 times 6 divided by 26. Find the parametric equation of the line that contains the points 1, 5, 2, and is perpendicular to the plane. So the normal to the plane n will be equal to 2, negative 4, and 8 from these values right here. We also need a point, and that's given. So from this, we can say x, y, z will be equal to, this will be a point, which is going to be 1, 5, 2, plus t, and then the direction, which is going to be 2, negative 4, 8. And we're asked for the parametric equation. So x will be equal to 1 plus 2t, y is equal to 5 minus 4t, and z will be equal to 2 plus 8t. And this is your answer. This is your parametric equation. And we're done.